Hello everyone. This is the continuation of our report in electrical standards and practices, the IEC or the International Electrotechnical Commission. My topics are IEC 61439 for low voltage switchgear, the IEC 60269 for low voltage fuses, the IEC 60364 for design, erection, and verification of LV electrical installations, the IEC 60086 and IEC 61427 for the batteries, and the IEC 60747 for semiconductor devices, and the IEC 60400 for wind energy. Let's start. Okay, so first is the IEC 61439 for the low voltage switchgear. The IEC 61439 lays down the general definitions and services conditions, construction requirements, technical characteristics, and verification requirements for low voltage switchgear and control gear assemblies. Note, throughout this document, the term assemblies is used for low voltage switchgear and control gear assemblies. For the purpose of determining assembly conformity, the requirements of the relevant part of the IEC 61439 series, Part 2 onward, applies together with the cited requirements of this document. For assemblies not covered by Part 3 onward, Part 2 applies. This third edition cancels and replaces the second edition published in 2011. It constitutes a technical revision. This edition includes the following significant technical changes with respect to the previous edition. A. Classification of the electric converter system, switch mode, power supplies, uninterruptible power supplies, and adjustable speed power drive system are tested to their particular product's standard. But when they are incorporated in assemblies, the corporation is in accordance with the IEC 61439 series of standards. B. Introduction of a group rated current for circuits within a loaded assembly and the refocusing of temperature rise verification on these new characteristics. Addition of requirements in respects of DC and D, introduction of the concept of Class 1 and Class 2 assemblies regarding protection against electrical shock. Okay, so next is the IEC 60269 for the low voltage fuses. So here, this is a set of technical standards for low voltage power fuses. The standard is in 4 volumes, which describes the general requirements, fuses for industrial and commercial application, fuses for residential applications, and fuses to protect semiconductor devices. So the IEC standard unifies several national standards, thereby improving the interchangeability of fuses in international trade. All fuses, different technologies tested to meet the IEC standards, will have similar time current characteristics, which simplifies the design and maintenance. So here is the parts of the IEC 60269. So for the first part is the general requirements. Second part is the supplementary requirements for fuses for use of authorized persons. So next is for the supplementary requirements for fuses used by unskilled persons. The fourth part is for the supplementary requirements for fuse links for protection of semiconductor devices. The fifth part is for the guidance for the application of low voltage fuses. And the sixth part is the supplementary requirements for fuse links for protection of solar photovoltaic energy system. Okay. So next is the IEC 60364 for the design, erection, and verification of LV electrical installations. So the IEC 60364 electrical installations for buildings is the International Electrotechnical Commission International Standard on Electrical Installation of Buildings. This standard is an attempt to harmonize national wiring standards in an IEC standard and is published in the European Union in CENELEC as HD 60364. The latest version of many European wiring regulation followed the section structure of IEC 60364 very closely, but containing additional language to cater for historic nation practice and to simplify field use and determination of compliance by electricians and inspectors. National code and site guides are meant to attain the common objective of the IEC 60364 and provide rules in a form that allows the guidance of person installing and inspecting electrical system. So here is the part of the IEC 60364. For the first part is the fundamental principle, assessment of general characteristic and definitions. And for the part 4 is the protection for safety. The part 5 is for the selection of erection of electrical equipment. Part 6 is for the verification. The part 7 is for the requirements for special installation or locations. The part 8 is for the functional aspects. Okay, next is the IEC 60086 for the batteries. So the IEC 60086 is an international standard that encourages the manufacturers of batteries to ensure that their batteries are interchangeable according to the standard form, fit, and function. This is intended to help end users as well as manufacturers of devices that use your batteries. Certification of the IEC battery standard show that the battery complies with the standard. What's more, interchangeability means the battery can be used in a much wider range of products, meaning you can boost adoption and revenue as a result. Okay, next is the IEC 61427, which is also for the batteries. This international standard gives general information relating to the requirements of the secondary batteries used in photovoltaic energy system, or the PVES, and to the typical method of test used for the verification of battery performances. This international standard does not include specific information relating to battery sizing, method of charge, or PVES design. Note, this standard is applicable to lead acid and nickel cadmium cells and batteries. It is intended to amend this standard to include other electrochemical systems when they become available. So next is for the IEC 60747, which is for the semiconductor devices. So the IEC 60747 series of semiconductor standards covers discrete devices, integrated circuits, semiconductor sensors, microwave integrated circuits, and other as part of its 28-part series. These devices are used as a building blocks for a wide range of more complicated devices. So standardization at this level directly contributes to the standardization of levels further down the design and the fabrication process. Okay, so here is the parts for the IEC 60747. So we have the general part. Next is the rectifier diodes, the signal switching and regulator diodes, the microwave diodes and transistors, the semiconductor lasers. We also have the photocouplers, the light emitting diodes, the transistors, the bipolar transistors. Okay. Next is the field effect transistor, the insulated gate bipolar transistor, the generic specification of sensors, the Hall elements, the pressure sensors, semiconductor accelerometer, the junction semiconductor temperature sensors, the isolated power semiconductor devices. Next is the amplifiers, the frequency prescalers, the frequency converters, the switches. Next, the oscillators. Then the technology approval schedule for monolithic microwave integrated circuits. The last part is the magnetic and capacitive coupler for basic and enforced isolation. Okay, so here the IEC 61400 standard, which is for the wind turbine. So the 61400 is a set of design requirements made to ensure that the wind turbines are appropriately engineered against damage from hazards within a planned lifetime. So the standard concerns most aspects of the turbine life from site conditions before construction, the turbine components being tested, assembled, and operated. Wind turbines are capital intensive and are usually purchased before they are being erected and commissioned. Some of these standards provide technical conditions verified by an independent third party and as such are necessary in order to make business agreements so wind turbines can be financed and erected. Okay then, the EC started standardizing international certification on the subject in 1995, and the first standard appeared in 2001. The common set of standards sometimes replaced the various national standards, forming a basis of global certification. Small wind turbines are defined as being of up to 200 meters squared swept area, and a somewhat specified IEC 61400 Part 2 standard addresses this. It is also possible to use the IEC 61400 Part 1 standard for turbines of less than 200 meters squared swept area. Uh, the standard for loads and noises are used in development of the prototype at Stride Wind Turbine Test Field. Okay, so next is the additional for wind turbines. So wind turbine generator or WTG classes. Wind turbines are designed for specific conditions. During the construction and design phase, assumptions are made about the wind climate and wind turbine would be exposed to. Turbine wind class is just one of the factors needing consideration during the complex process of planning a wind power plant. Wind classes determine which turbine is suited for the normal wind conditions of a particular site. Turbine classes are determined by three parameters: the average wind speed, extreme 50 years gust, and turbulence. Okay, so that's all. Thank you for listening.